At a glance, it might seem to especially astute listeners that machine learning only works if you have unencumbered full access to the entirety of your unencrypted dataset. And that's not actually true, as we're going to find out today in this, the 11th installment of Data Skeptic Consensus, our series about how multi-agent systems achieve collective decision-making. Today on the show, I speak with Clement Fung about his research into federated learning. It's a distributed approach to machine learning that protects privacy and works great if every participant plays fair. But not so if participants engage in something called Sybil-Based Attacks, in which one actor tries to play the part of many.
Hi, my name is Clement Fung. I'm a PhD student at Carnegie Mellon University.
Welcome to the show.
Thanks. I'm happy to be here.
So tell me a little bit about your specific areas of study.
Yeah, so at Carnegie Mellon, I'm a PhD student in the School of Computer Science. And more specifically, I do research in, let's say, the broad category of computer security. And if you want to drill down even further, I mostly work in security when applied to machine learning systems and the security of machine learning systems.
I would guess the audience has at least some familiarity with security as being like, denial of service attacks and very rule-based kind of system looking at traffic. Maybe not as much in machine learning. How does security play into machine learning operations?
Yeah, absolutely. There are many different levels, I think, that you can approach the problem. There's the initial idea of just taking traditional security problems, such as denial of service, intrusion detection, and applying machine learning to those domains. Just gathering insights from data and learning about them. And then there's the more meta area of making the actual process of machine learning more secure. And so there's been a wide array of work in the community that has shown how at test time, you can perform different types of attacks. During training time, you can perform attacks on the model and pretty much anything in between.
I'm sure you're familiar with this phrase that if you're not paying for the product, you are the product. And I guess there's some wisdom in that. I don't know if it's universally true, but people are certainly becoming more aware of that. And maybe the off-the-cuff reaction is, I don't want people having my data because it's privacy. But in some sense, I would like people to have some of my data. I don't mind having good recommendations on Amazon, for example, because I can just ignore them. Where do you yourself draw the lines about data sharing?
Yeah, so I agree with you that this is a pretty personal choice when it comes to just the type of experience you want to have with the product. I think I would be similar to you in that respect, where nothing comes for free, as you've said. You're going to have to give some data to a system to be able to use it and to be able to use it effectively. I think it's a really big area of research in general about ways in which maybe you could provide data to a system, but do things in a more privacy-preserving way. So that's a very big area of research these days. I guess I'm a user of most everyday things, so that's where I would lie on the spectrum.
Makes sense. Yeah, I think that's most of us, perhaps. Well, the specific paper I invited you on to discuss today is titled The Limitations of Federated Learning in Sybil Settings. So I guess some definitional questions to kick us off. What is federated learning?
This is great because it kind of plays into the idea of privacy a little more. Federated learning is this new idea in distributed machine learning that came out in around 2017, developed by Google. And it's the idea that you can train machine learning models across distributed data sets over the network without actually transferring data into Google's domain. So, previously you would have the idea that I'm using a service and some server, let's say that's owned by Google, would be collecting all this information and storing it somewhere on a database and then running machine learning on that collected data. Federated learning is a different idea where instead of storing data on a database owned by Google, they actually just do the model training kind of live as it's occurring. And there's no transfer of data. It's just machine learning that occurs over the network. And that might sound like it's kind of the same thing, but when it comes to the problem of data ownership and privacy, there's a bit of nuance there in terms of both the privacy and security implications of federated learning, which is one of the big topics of our paper.
And when the model's being trained, where does that training actually take place in the situation of federated learning?
I guess you could think of the machine learning process as kind of just an iterative summation of values. So the training still takes place over the network in the sense that you're taking updates to a model, like you're learning it, by adding values, but the values are passed over the network directly. So it still lives in the server's domain, just that the data used to supply those updates does not. It still stays on the client devices.
Gotcha. So if maybe we take a simple case of something like the logistic regression, which can be nicely summarized as just its beta values, just the parameters that were calculated in machine learning, would it be correct to describe it as saying like my phone or my local device or whatever looks at my private data, calculates that model, and instead of sending my data, just sends those parameters off to Google?
Yeah, that's exactly right. That's like a really good way to describe it.
Gotcha. Okay, so we're synced on that then. Don't I still have some sort of privacy risk, though? Because someone could kind of invert that and say, well, if you're sending us these parameters, what's the data that would have arrived at this answer?
Exactly. So there's a whole field of research on privacy attacks on federated learning. We discussed this a little bit in our paper, but it's not really the focus of our paper. And the idea behind all of these attacks is very much what you just said, which is maybe I can't observe the data used to train the model directly, and that provides some sort of privacy. But if I can observe the model updates or the beta values, as you're saying, and observe multiple instances of them over time, I get a pretty good idea of what your data looks like. And there's some, mathematical theoretical bounds on how much you can do, but in practice, that might already be too much for certain contexts.
Gotcha. So we should probably get into Sybil settings, but I'd like to get your take on one other idea before we move into it. I guess I'm going to put on my very pessimistic hat here. I don't want to start a fake controversy, but do you think it would be fair for someone to be upset by this, to say Google is using my CPU and my power to compute a model to do something to me, and all they've done is move the compute off their servers onto my hardware?
Yes, so I will say in the defense of Google, the original motivation of federated learning is to be very compute efficient. So they do a lot of work when it comes to compression and ensuring that the whole process is optimized. I haven't looked at the original paper in a while, but there are some kind of ways that they reduce the network costs as well. I think that's an interesting way to think about it. At the end of the day, you're still running some client process on your Android phone. And it's true that there's additional processing that occurs now that federated learning is being used. But in my more optimistic point of view, I don't think that's too big of an issue.
Yeah, I would tend to agree. I just didn't know if that was universal.
Yeah, I wouldn't say so. At least the compute isn't really the problem here.
Well, let's get into Sybil-Based attacks. Can you give us a definition of what that is?
Broadly and somewhat informally, I would define a Sybil as a fake alias or a fake account that you create in a system to gain additional leverage. Traditionally, Sybils are kind of a big topic when it comes to the Internet of Things or social networks. There's a lot of work in computer science that has shown ways in which you can make bots on Twitter to manipulate many objectives. And we look at federated learning, which is a distributed system and has varying incentives as well, as another application for Sybils.
Obviously, it sort of makes sense. If I want my vote to count, the best way to do it is to duplicate it, have a bunch of clones, and be counted n number of times. Are there any theoretical boundaries on this kind of stuff? Could I compute something like how many fake accounts I would need to have an influence?
Are you talking specifically in the domain of machine learning, or?
Well, I guess either way, whatever you think is a more interesting angle.
Sure. I think broadly when it comes to the space of your Sybil attack, yeah, definitely. So I think completely eliminating fake accounts in any system is really difficult. That's why a lot of traditional services will do things like force you to tie accounts to a cell phone or to an email address. So that just increases the cost of making these fake accounts. And I think the whole idea there is maybe you could make, a second Facebook account, and that could give you an advantage in the system, but you probably couldn't make like 1,000 of them. And I think it's all about kind of increasing that cost to kind of make that theoretical trade-off when it comes to executing an attack more and more infeasible.
Thanks to this week's sponsor, Brilliant. Listeners, I imagine by now you're aware of the online learning platform Brilliant. I'm a big fan, and this week I want to throw you a slight curveball. I think you should go check out their Geometry Fundamentals course, an intuitive introduction to the essentials of geometry, 24 interactive quizzes, and 255 plus concepts and exercises. Now, why this one? Many listeners already know the geometry fundamentals. However, not all listeners know machine learning fundamentals quite as well as they often think. And I find the geometric interpretation of machine learning is very helpful, picturing surfaces and gradient descent and optimization criteria and things like this. I would have built that a lot faster if I had had the examples that Brilliant provides. They're interactive, unlike the flat textbook examples I learned from, and you may just find yourself having a whole new fundamental insight into the way things fit together. And honestly, you will lose yourself in these fun quizzes like they're puzzle games anyway. If geometry fundamentals is not your cup of tea, there are plenty of other courses to choose from. Brilliant.org/dataskeptic will get you 20% off Brilliant Premium. It's fun and affordable. You really should check it out. Brilliant.org/dataskeptic. Yeah, I guess that's a good point. If I opened up some poll, let's say, where anyone with an IP address could come vote, it's pretty easy to get new IP addresses. But a LinkedIn account, not so easy to get a couple of those going without some heavy-duty kind of jumping through hoops and stuff like that. Do you think that ultimately that's the way we should solve this, just to put up enough barriers that it's not worth doing? Or I guess the other approach might be to assume we have these bad actors at play and have methodologies that work around that.
I think depending on the context, both are entirely valid. The way we've written our paper when considering federated learning is pretty neutral, but in some contexts, like LinkedIn, for example, maybe it's not such a bad thing and you could design the defense more internally, I guess. Yeah, I guess you can defend Sybil's at the account creation step or at the more deeper algorithmic system step. And I don't think there's a total consensus on what makes more sense. I think it's context dependent.
And I know this is an area where some of the innovations described in your paper start to cover how we might detect these, but let's maybe take a step back and say, before we're going to prevent the attacks, what have some of the historic methods been for even determining if you're a victim of such an attack?
I would say a lot of the ideas we have even here are kind of motivated by social networks, which was a big space for Sybil's maybe 10 years or so ago. And people kind of just design different heuristics and metrics to evaluate how malicious an account looks. So one thing that's well known in social networks, for example, is that accounts with more connections are more valuable. And while it's easy to make accounts and have them connect to each other, it's difficult to form a connection with a genuine account. And that's actually why you get like friend requests from bots on Facebook or Twitter all the time, because all these cloud systems, they know that just raw follower count or raw, friend number isn't really a good metric. They'll use some sort of graph algorithm, for example, to measure how genuine your account is.
We'd mentioned the example of Google. Are you aware of any other common use cases where people are applying federated learning?
It's relatively new, so I'll say concretely no, but there are definitely research papers and blog posts which maybe aren't the best source, but they do discuss things like federated learning entering the healthcare domain, federated learning being used in startups to facilitate like data marketplace type exchanges. And I don't know if there are real solid concrete winning use cases for federated learning just yet, but it's certainly an area of interest for those domains. Healthcare being a big one too, because privacy is such a big topic in healthcare, and they've really started to look at federated learning as at least a way to help with that problem.
And these Sybil attacks, or really any kind of attack, but these in particular would be a hindrance to adopting federated learning. If it came public that, it was super easy to do these things, well, that weakens the approach. Do you have a take on it? Is this really an unlikely circumstance or a David and Goliath type situation? How difficult would it be to pull off a Sybil attack?
I think the argument I pose, at least in our work, is that maybe if you're Google running federated learning and you have at least millions, maybe billions of users at this point, it's probably pretty hard to execute an effective Sybil attack. You'd probably need an overwhelming number of compromised clients or fake accounts in the system. But when more and more you're starting to see federated learning applied to kind of more sparse, more fringe startups or IoT settings, I think that's where it starts to get more risky. I think the big issue really is just that federated learning is really just a machine learning algorithm optimization technique that makes additional security assumptions in its design. And people are kind of applying federated learning without really considering those assumptions as well.
Well, let's get into fool's gold. Can you tell us a little bit about the algorithm?
At a high level, fool's gold is motivated by the idea that, it's really easy to execute attacks on your system. So fool's gold is targeted towards poisoning attacks specifically. So maybe we should define that first. A poisoning attack is an attack where a malicious user provides malicious training data to a shared training process and manipulates the behavior of the shared model. So this, outside of the context of federated learning, this can be done as well. I think some of the early examples might have been spam filtering, where you could open some accounts and mark things as not spam, and it would start to affect how the machine learning model performed. In federated learning, you can do the same kind of thing by supplying malicious updates to the model. And one key thing we talk about is you can make malicious identities or aliases in the system without even generating additional data. So you could just have the same amount of data in the system, just more accounts. And most poisoning attacks that you would think of become much, much stronger when you're able to do that. So Fool's Gold, maybe a bit of a corny name, but is the idea that you want to be able to differentiate between these model updates that are genuine and actually have benefit to the global model, and filtering out the ones that are kind of copies or low value, or you can easily tell that they're from the same underlying malicious data distribution. I guess without going into too much detail, the whole idea is that if you start to see updates from a specific group of users that all look very similar, it's likely that they may be malicious, and Fool's Gold kind of recognizes that and penalizes those updates.
In principle, it sounds, directionally correct and has the right ideas. I'm curious about like a situation of a false positive. Some, minority community comes online all at once because they were very, interconnected, and somebody introduces a new service to that group all at once. You could have a lot of seemingly similar ideas all coming online and maybe look suspicious, but that's at least the way I framed it, a legitimate use case. How do you tell the difference?
This can definitely happen in Fool's Gold, and it unfortunately comes down quite a bit to the parameterization of the algorithm. I guess one thing I'll add is that one additional marketing point of federated learning is the ability to train over very different data sets or non-IID, not independent and identically distributed data when performing machine learning. So there's a bit of an underlying assumption that you're going to have some diversity amongst your honest users when running federated learning, but certainly the false positive case is possible if not parameterized well. And we show this in our paper too. Fool's Gold isn't like a perfect defense that'll handle everything. And it certainly can fail in certain scenarios when it comes to the underlying data distribution amongst clients.
Could you contrast it a little bit with some of the other techniques that are out there? What advantages do you get, and is there a cost? Do you pay a computational fee, so to speak, to achieve a better result?
I think our work is likely one of the first, or the first that I know of, that really considers Sybil at the core of its design. So there's other work that is aimed to prevent poisoning attacks and other malicious attacks in federated learning, but I would say essentially many of them are kind of outlier detection techniques. So they'll get an incoming stream of model updates and they'll look at what the average kind of looks like. It's not as naive as the average, but something like that, some sort of summary statistic. And they'll just say anything that looks too far out of distribution, looks like an anomaly, are things that we will remove. So those are good defenses that work under the right conditions. And the big difference in Fool's Gold is that we design a different aggregation function that considers, if there are enough Sybils in the system, you can manipulate the distribution of the model updates. And a lot of these outlier detection models don't actually work so well. Computationally, things are about the same. I just think we are a little more designed for that type of attack as opposed to the prior work in this space.
And tell me a little bit about maybe scope and data size. How big does an attack have to get before it comes on the radar of Fool's Gold?
We actually show in our work that pretty much as soon as you start entering even two Sybils, like as soon as you have two Sybils that are using the same underlying data set, Fool's Gold does quite well at handling those cases and removing them. And it actually scales well even as the number of Sybils increases, because really at that point, it's just a copy-paste attack of more and more of the same stuff coming in. And Fool's Gold is able to detect those cases as well. Our evaluation is kind of only really shown on some of these academic, simple workloads that just exist, like, those free data sets, data repositories. But theoretically, there isn't really anything that should prevent Fool's Gold from working on larger models and larger data sets.
Thanks to this week's sponsor, BetterHelp. BetterHelp is an online counseling service. It's convenient, professional, and affordable. BetterHelp will assess your needs and match you with your own licensed professional therapist. It's online, so you're connecting into a much wider network than you'd find in your local area. Start communicating with them in under 24 hours. It's not self-help, it's professional counseling. Send a message to your counselor at any time and you'll get timely and thoughtful responses. Plus, you can schedule weekly video or phone sessions. BetterHelp is committed to facilitating great therapeutic matches. They make it free and easy to change your counselor if needed. It's more affordable than traditional offline counseling, and financial aid is available. If you want to start living a happier life today, as a listener, you'll get 10% off your first month by visiting our sponsor, betterhelp.com/dataskeptic. That's betterhelp, HELP.com/dataskeptic. Let's talk a little bit about those data sets that are available, because as you said, this is a very new idea. There isn't necessarily a lot of, I don't know if precedent's the right word, but you don't have the data sets and things the way you do in other cases. How can you take something like MNIST and make it useful in this context?
Yeah, so MNIST is one of the data sets we use in our paper. It's obviously a bit of a fabricated scenario because the way we set it up is that we scramble the underlying distribution of digits. So we'll show cases where every single client only has images of a single digit, which, isn't so realistic. People probably write more than one digit in practice. Or we do other types of scrambling where, certain digits are more prevalent in some clients than others. But there are other cases, especially health and image, like selfies or images of yourself, that kind of have this underlying data split and distribution assumptions. This is really recent, but I think in the last year or so, there's been a bit of a push in the community as well to provide better benchmarking scenarios for federated learning. And I think there is some research work that's trying to kind of in the same way MNIST is, or at least used to be, a benchmark in standard machine learning, developing other types of like federated learning benchmarks when designing new algorithms, attacks, and defenses.
Yeah, I'd be very glad to see things move in that direction nicely. I'm excited about how this field develops. I don't know if you follow the GANs community particularly tightly, the generative adversarial networks, but there's maybe not similar, but there seems to be a cat and mouse game there that someone will produce a new, not just in the sense that you have the discriminator and the generator kind of competing, but keep seeing these papers of, hey, we detected deep fakes using the way people blink, for example. And a few weeks later, a paper comes out and now they can generate deep fakes that blink. And it kind of is very competitive in that regard. Do you imagine a similar procedure happening here as federated learning grows in popularity?
Unfortunately, probably yes. I think when it comes to machine learning research, especially because it's a very hot space, you're going to see new attacks for new defenses quite rapidly in this community. So I do see it being similar, just attacks and defenses being designed for one another in this rapid, tight cycle.
Are there any particularly nefarious versions of this that you'd be concerned about? I know in the case of what Google was trying to do, I believe it was for like predicting context around search. So like if I'm in my car and I search for pizza, I want a pizza restaurant, whereas at home I just want delivery, kind of things like that seem pretty harmless. What are the worst case scenarios here?
That is a little bit even remains to be seen because federated learning is so general. It depends a lot on what context it's being applied to. That being said, distributed machine learning and distributed training is certainly getting more and more popular. I wouldn't be surprised to think that, let's say in self-driving, for example, which is such a distributed setting, you have all these cars, it's unlikely you're going to want to centralize everything live. I could see federated learning being a use case for self-driving. And there are some pretty clear bad security problems there if models start to get compromised. I think it's context dependent, but federated learning is so widespread that really critical domains like self-driving, and probably more that I'm not even thinking of right now, could definitely be victim to it.
If I understand correctly, Fool's Gold is really a detection or labeling algorithm. It'll help us say these seem to be attacks versus these seem to be regular attacks. Not all that different from a spam filter, I guess. I think Fool's Gold probably stops there, but I'm curious to get your thoughts on what do you do next? Do we, try and do something against that user, like block them, or do we let them keep submitting and do something like a shadow ban? What procedurally should an ML engineer do when the Fool's Gold red light goes off?
Yeah, I think that's a great question. Shadow banning or removing is probably an ideal scenario, I don't know. I'm not sure if I can think of anything much more clever than that. In the typical Sybil case, that's probably what's going to happen, right? Someone reports that this account looks like a bot and it gets shut down. And I think those types of defenses and solutions applied to federated learning could be just as realistic. I guess you also have the additional problem of, depending on how good your provenance is in your machine learning system, if you detect that some client has been behaving maliciously, and let's say you haven't detected it and it's been months, you could get a good idea of what type of models those accounts have been exposed to or participated in when training. And if you have a good idea of what exactly those malicious accounts were doing, you could investigate the models as well, in addition to a shadow ban.
I don't see that the particular algorithm being used makes much difference. I've referenced logistic regression a couple of times, but I don't see why we couldn't do decision trees and deep learning and stuff like that in a federated context. Are any of them better or worse in terms of getting attacked?
I would say, and this might be more of an opinion than a fact, but I would say that the attack surface increases with the complexity of the underlying model. That's why, for example, adversarial examples are so prominent in the deep learning space, because you just have more parameters to play with and a much larger input space that gets considered and just more knobs to tweak with. It's easier to find an example that attacks that model. When you have models like logistic regression or decision trees, they're a bit more simple, which isn't necessarily a bad thing, because most people would consider those models to be more interpretable or more explainable, and maybe not directly, but that kind of does relate to how attackable a model is. So I think these really big, complicated deep learning models are kind of the most at risk, because they're used in such wide contexts and they have a lot of black box internals to this date that aren't well understood, which makes them much more susceptible to attack.
That's a really interesting answer. Yeah, absolutely. Fewer parameters does seem to leave room for fewer risks, I guess, or less room for risk.
Yeah, definitely, yes.
Well, usually at this point in the interview, before I go into some wrap-up, I like to ask, is there anything you think we should have touched on that we haven't yet, besides the conference, obviously, that I'll get to?
Not too much. I think just the wide scope of different attacks on federated learning that the community is doing as well as exploring. So in our paper, we actually do a pretty good job, I would think, of categorizing this space. We talked a lot today about model integrity, kind of just making sure that models predict the right thing. But there are other attacks on federated learning. Privacy is one that I touched on a little bit, but there are other things you could do too. Some work has shown, for example, that you can join a federated learning system and maybe you're not directly attacking it, but you're kind of sending nonsense to it in hopes of receiving a payout. So that's kind of this like data exchange, data marketplace kind of. It's called a free rider attack, and probably you could Google it and find it, but there's a paper too where you just join these federated learning systems, you kind of send nonsense data or like copies of other data that you saw earlier in the training process, and you try and get a payout by doing so. We also talk about another type of attack in our paper, which we designed actually, in which maybe federated learning is this shared compute, and you could join the system and kind of toy with the training process such that it takes infinitely long, for example, or maybe not infinitely long, but longer than it should have. And I think that's another pretty interesting avenue of attack that isn't well explored or discussed by the community right now.
Yeah, it seems like there's a lot of open threads here that future research will hopefully explore. With that in mind, how eager or, I guess, avoidant do you think maybe someone should be? They're thinking of, I don't know, starting a startup, or a company wants to embrace federated learning for their use case. Maybe what percentage of their time should they dedicate to worrying about these sorts of risks?
I will definitely give a biased answer because I'm a computer science security researcher. So my percentage would probably be like half at least. But I just think if you're going to enter this space and you're trying to make a startup around federated learning or use federated learning as a major piece of technology in your infrastructure, be well aware of the space of attacks on machine learning and how they are made or potentially made even more possible or stronger in the context of federated learning.
Definitely. I think good advice there. And what's next for you in this line of work and this paper specifically?
So this paper specifically, I guess I'll present it and kind of see what kind of feedback I get. But as you and I have been talking, there's just so much work in this space when it comes to different attacks and defenses. A lot of these model utility attacks are just so new, like all within the last year or so, that I think it's a pretty interesting research area. And personally, I might dig into that a little more.
Well, very exciting stuff. I'm looking forward to reading more. Clement, where can people follow you online?
I'm not huge on social media, but I do have a Twitter at Clement Fung. I also have a personal webpage. If you have specific questions about any of my research, I'm always happy to receive emails. Other than that, I don't think there's anywhere else.
Fair enough. Well, we'll have links to that in the show notes for people to check out. Well, thanks again for taking the time to come on the show and share your expertise.
Oh, no, yeah. Thank you very much for having me. And I hope everyone kind of thinks about Federated learning a little differently when they see that next, marketing post somewhere.
Definitely. I hope so. That concludes this installment of Data Skeptic Consensus. Our guest today was Clement Fung. Our theme song is Paradox by Odling. Claudia Armbruster is our associate producer. Vanessa Burciaga does guest coordination. And I've been your host, Kyle Polich.
What do you get when you cross a Comic-Con with a science fair? You get an amazing online event. And best of all, it's one that's produced by us, your friends at Skeptoid. You're invited to Outpost 2020, our new virtual fandom con, happening October 23rd to 25th. And wait, you're saying that date has already gone by? Well, luckily it doesn't matter. Sessions at the Outpost remain live for a full month. The Outpost features panels on science fiction, gaming, fantasy, and more. Wait, you're saying why is Skeptoid producing a fandom con instead of a skeptic conference? Well, if you know Skeptoid, you know we're always trying to expand the audience, to bring our brand of critical thinking to the people who need it most. The people who love science fiction and gaming and fantasy. The people who are, right now, where so many of us in science communication started. We invite you to Outpost 2020. Get your tickets now at outpostcon.com. Tickets are just $25 and you get all the content through November 25th, 2020. Outpostcon.com.